In this lesson, we're going to discuss factoring completely. Now, most of the problems we've done up to this point have only had one step of factoring, and the problems we're going to deal with here have multiple steps, usually only two, but sometimes three. Now, step one for every single problem, whether it has it or not, we're going to look for a greatest common factor, a GCF. Now, the greatest common factor is really simple. It's the number that all the terms have in common. Now, we're going to start off with a pretty simple example, 2x plus 6. Now, when I look at 2x plus 6, I'm looking for a GCF. In this case, the common factor is 2. If I take a 2 out, that leaves behind an x plus 3. Now, if this seems simple, that's a good thing, because it is simple. And it's a necessary step to look for this on every single polynomial we try to factor in this chapter. Now, if that was simple, we'll move on to the next example. Now, in this example, we have a trinomial. And again, step one is to look for a GCF. In this case, the common factor for all three terms is a 5. So we take out the 5. We get x squared plus 3x plus 2. Now, on the previous example, we only had to do step 1, and we'd factored completely. But now it's time to talk about step 2. We've got to deal with what's left behind in the parentheses. A trinomial. In this case, a trinomial that can be factored. So if it can be done, we do it. X times x, 1 times 2, and plus and plus. Now, if you have any questions about that answer, you can definitely do the FOIL method and make sure it works for you. So it turns out step 2 is pretty easy. After you take out the GCF, factor what is left behind. Now here's another example. We're going to start by factoring out the GCF. In this case, the GCF is 2. And that leaves behind x squared minus 9. And again, what's left behind in the parentheses can still be factored at least one more step. In this case, hopefully we recognize the difference of two squares from a previous lesson. And we'll write x and x, 3 and 3, and plus and minus. So this step 2 really just depends on what's actually left behind after you take the GCF. Different kinds of factoring, but the same idea. We've just got to finish the job. Now, this last example is probably the most complicated. This is a polynomial with 4 terms. 4 terms makes me think of factoring by grouping. There's no common GCF, nor normal step 1, so we have to go straight to the factoring of the polynomial. And in this case, factoring by grouping, looking at the 2 terms at a time, and I think we can get this done. In the first 2 terms, the common factor is x squared. X squared is taken out. That leaves behind a 2x plus 3. Now for the second 2 terms, when we look for the common factor, I believe it's negative 4. But when you take out a negative, remember, you're dividing by a negative 4, which leaves behind a positive 2x and a positive 3. Now that I've factored by grouping, I can notice there is actually a GCF for these 2 terms. In this case, the common factor for both of these terms is 2x plus 3. And if you take a 2x plus 3 away from both of those, that leaves behind x squared minus 4. Now, in a lot of cases when you do factoring by grouping, that's all you need to do. But in this case, because the instructions are to factor completely, we've got to double check what's left behind. Now, this first parentheses, no problem. It's done. There's nothing else to factor. But this second parentheses certainly looks like difference of 2 squares to me, and that means we have one more step. Now, we'll start off by writing the 2x plus 3 because we're not done with that yet. And then we'll factor the x squared plus 4. Got to fix my parentheses. And we'll get x plus 2 and x minus 2. And now we factored it completely.